So for today's lesson, Gracie Joe here wanted to apparently help out with the lecture. Say hello to the people at home, Gracie Joe. Hey, look. Say hi. I know. Who's that? So she sends her best and hopes you all have fun coding today. Hey everybody, we're about to start activity 2, temperature conversion. This is our activity walkthrough video for lesson 2, data types and expressions. Today we've learned how to express numbers, characters, and true and false values as variables, and we've learned how to use those variables in expressions. So you've already got the tools to do some pretty complicated operations in Java in just a couple days. So you should be proud of yourselves, give yourselves a little pat on the back, but I don't want to take up any more of your time with this little chit-chat, so let's get right to it on activity 2. So for the lesson 2 activity, we're going to do create a temperature converter. We're going to convert Fahrenheit values into Celsius, I believe. Or is it actually convert Fahrenheit to Celsius? Yep. First thing it asks you to do, though, is to import code examples into Eclipse. These are actually authorized Boise State code examples. So Boise State has compiled a CS121 repository, which is just a fancy word. It's like Google Drive for code, basically. It's a whole repository of examples for all the different chapters of CS121, and you can go and look at different examples of code that solve different problems or illustrate different concepts. And today we're going to be importing those examples into Eclipse. So again, these examples assume that you are using Onyx and you're in the computer labs at school. We are not in the computer labs at school. So you can skip steps 1 and 2 and go to the part where it says when Eclipse loads. So when Eclipse loads up, we're going to import our CS121 examples. So to do that, the first thing you're going to want to do is copy this URL here. This is actually the link to all of our Boise State repositories on GitHub. So we're going to go to File, Import. And we want to import files from Git. So we have to go here. Git is a really cool, it's called a version control system. We use it in software development all the time. Basically, it helps you track the changes on your project and keep changes that you want and kind of see the project evolve over time. If you have more questions on that, it's pretty cool. Hit me up in office hours. I'd love to talk about Git, GitHub, version control, what all that stuff is. But just know, pretty much here we're using it just as storage for all these examples. So like I said, pretty much Google Drive for code. Now we're going to be cloning it from a URI or URL. So looks like it took the one off my clipboard. Pretty awesome. And we're going to hit next, next, and next. And it should show up in my Eclipse workspace if it imported successfully. And there they are. Chapter 1, Chapter 2, we've got all of our CS121 examples in there. And they're all inside of that default package, as you can see. So that's step 1. You can slow that video down and look through it, follow these steps to import them in your own workspace. Basically, paste that correct URI in there, and just click Next for the next 2 screens. Import existing Eclipse projects, which should already be selected. And you're done. So now, it's time to write our program. I've already demonstrated to you how to use Eclipse in lesson 1, so we don't need to worry about this project setup stuff. But it's a good reminder if you haven't been using Eclipse yet, so highly recommend you read through these steps just to review. And on this lesson, the actual directions for the activity are right here. So first thing we're going to do is create a new class called myTempConverter. So we're going to go to our Activity2 project, open it up so we can see it. We've already got a file in there from the lecture. I'm going to create the class it asked me to. myTempConverter. And I believe it uses capital C, so I'm going to change that. We want to make sure we're using the exact same file and class names that it does in the activity directions. Otherwise, we run the risk of being marked down because the grader might have trouble running your program. So definitely make sure that all the casing is the same. And now, on step 3, all it said is just name your class, make sure it's in the right place, which we already did for step 2. Now for step 3, open the existing tempconverter.java program and the chapter 2 examples that you imported in part 1. Use this as a reference for creating your own version of the application that will convert a Fahrenheit temperature to Celsius. And there's a nice little example of it in the textbook if you got it. Instead of reading the temperature from the user, which is mentioned in the textbook, so if you are looking at the textbook, they read the temperature from the user. We're going to explore user input in the next lesson, so don't worry about that. We're just going to code the value in. So first of all, let's go open up that tempconverter.java program from the chapter 2 examples. Open that guy up, and you'll see demonstrates the use of primitive data types and expressions. That's what we're getting at here. And this computes the Fahrenheit equivalent of a specific Celsius value. So here's the mathematical formula. So Fahrenheit is 9/5 times Celsius plus 32. If you're familiar from your science class, I haven't seen that formula in a long time. So our base value is 32. We have our conversion factor here, which we got to make sure it's 9 divided by 5. We don't want to get 1, so we need to use decimals here, so we get the appropriate conversion factor. And these are just two constants that we use in our formula. And notice that they've got those down. Your actual calculation occurs right here, where we have our Celsius temperature we're going to convert times the conversion factor plus the base. And notice that's where your C is, right here. So the Fahrenheit temp is the value that we're assigning our formula into. So this is the actual value we're going to print out at the end. And it's kind of, like I said, stuff's kind of in a weird order here. We've got our constants up here, then we have the value that we actually want to get and save as a variable. Then we have Celsius temp, which is actually the value we want to convert. So if you want to change the number up in your program to test it, this is the number you're actually going to change, Celsius temp, or in our case, Fahrenheit temp. And this is where the actual calculation occurs. So this is where we calculate the Fahrenheit temperature from the Celsius temperature. And then we're printing it out down here. So we print out our original Celsius temperature, the one that we coded in up here. And then we're printing out our Fahrenheit equivalent down here. So this is the value that we actually calculated. So if we run this, 24 degrees Celsius is a nice, perfect 75.2 degrees. So now, what we want to do is copy this program over, and we can actually copy it, paste it in ours. There's our main method and everything. And what we want to do is change this to instead convert a Fahrenheit temperature to Celsius. And we can do that just by switching around the math a little bit. So, first of all, notice that the curly braces here are a slightly different style. A lot of the examples are done in this style, where the curly brace is on the line below. This is totally valid. However, I have looked up the official Java conventions, and the official Java conventions are to put the curly brace on the same line, kind of at the end. I like that because it saves me a line of code. That line forward doesn't really need to be there. So I can backspace up, shorten up my code a little bit, and I think it reads kind of nice, where you read your line of code, you're like, okay, this is the main method, boom, there's my curly brace. I don't have to look down below for it. Now, if you like this style, it's totally okay. I won't mark you down for it. Some people do prefer that, and a lot of programming languages use this style, but I do personally prefer this. So, but it's up to you. And that's another cool part of coding is everybody has their little preferences, and sometimes we get in pretty heated debates about it. Kind of fun, but this is one that for this class really doesn't matter. So let's talk about how to convert this. So this is where I actually really find it helpful to write down the formula. So they've already done that here in a comment. So I'm actually going to take my notebook and I'm going to write this formula down. F equals 9/5 degrees Celsius plus 32. And so what we want to do to actually have this be Celsius temp, so the next thing I want to do is I'm going to switch these variables around. So I'm going to call this Celsius temp. Notice we're getting a duplicate local variable warning here, so let's change this to Fahrenheit temp. I think that's how you spell it. And let's convert this to like 75 degrees Fahrenheit. And we'll just be using ints for this program. We don't need to use doubles. Actually, you know what? No, sorry. Yeah, so the value we're inputting is just going to be an int. So that'll show us some nice type promotion behaviors. We're going to use Celsius temp equals Fahrenheit temp. And obviously this isn't going to be correct. I'm just switching them around. And I want the Celsius temp to print second, so we get what we inputted and then what we are outputting. Whoa, maybe I did spell it wrong. I'm just going to copy what they had. There we go. Got rid of those spelling errors. So what I've done is I actually wrote down this formula in my notebook here on the side of me. And I'm actually just going to use algebra to solve for C, because now we want to get our Celsius temperature. We've declared it up here. We're saying, hey, this is the answer to the formula we're going to do. Here's our input value, and here's the result of that. Now, you also, if you don't like this, you can totally do that and have Celsius temp just be declared and initialized here. In fact, I kind of prefer that, so I'm going to leave it this way. I think the code reads a little easier. So we've got our input, then we got our calculation, then we got what we're printing out. So let's get back to actually figuring out what our formula is going to be. So I have F equals 9/5 times C plus 32. So the first thing I want to do to solve for C is subtract that 32 to the other side. So I've got 9/5 C now equals F minus 32. Now I need to divide that other side by 9/5. And to divide fractions, of course, you multiply by the reciprocal. So now I'm getting C equals 5/9 times Fahrenheit minus 32. Sorry for that awkward cut. I had to double check my math. Just so you know, that's why I do computer science. The computer does the math for me. On these rare occasions, though, sometimes you do have to do some math, and you do have to multiply the whole side by 5/9, which, you know, maybe that seems silly to you, but you know, it's been a while since I've just done straight up arithmetic. You know, shows you how much you really take for granted, and really gives you an idea. You know, are you really going to use this in the real world? Yes, but maybe not every day. Enough to kind of forget. So our formula is Celsius equals 5/9 times the whole thing, F, your Fahrenheit value, minus 32. So I'm going to go ahead and I'm actually going to make a comment up here. And I'm actually going to make a special type of comment called a Java comment, which is when you do /**. So it's the same as a multi-line comment with the extra star. You get this nice blue comment. And this actually is an official Java convention, Java docs. And there's actually a button up here that allows you to generate, I believe, you can generate documentation from your Java doc. So Eclipse will actually read this comment and produce a little web page that has a description of your myTempConverter class and lists you as the author. So I'm just going to say, I'm going to describe the purpose of my program up here in my Java doc. We actually require you to do this in your projects, but I'm just going to say converts a Fahrenheit, still don't know how to spell Fahrenheit, value to Celsius using the formula that we figured out in our notebook. C equals 9 divided by 5 times F minus 32. So there's our good old formula. So now we know what we need to do to switch around this. So we're going to do Fahrenheit temp minus space times conversion factor, and we do have to reverse our conversion factor. So now it's 5.0 divided by 9, and remember, you don't need the 9.0. 9 will get promoted to a double when it gets when Java does the operation here, because 5.0 is a double. So now we've got conversion factor times Fahrenheit temperature minus space. So we're ready to test. And notice our constant is 2 words. So when you have a constant in that capital case, that's 2 words, you use an underscore. And this is actually called screaming snake case. Snake case being snake case like that. Some programming languages like PHP like you to name your variables that way. That's called snake case, but because it's all caps, this is called screaming snake case. And so now let's test it out. So we already got the answer. 24 degrees Celsius is 75.2 Fahrenheit. So 75 degrees Fahrenheit should be about 24 degrees Celsius. And indeed, 23.88889. And that's something you'll find out, is that a lot of times our double variables, you can see doubles can only contain so many decimal points. So computers actually aren't very good at being super duper precise with calculations with numbers with decimal points. It can only represent so many, and this would normally, I believe, be 2.8888 repeating. But we've got, 23.888 repeating. But notice we got a little margin of error there. And there is a certain degree of margin of error with double calculations in Java that you do have to account for. Don't run into that a whole lot, at least at my job, but I know probably at banks and workplaces like that, that does become important. So we can dig into that a little bit during office hours if you'd like. I think that'd be something fun to dig into. Something I haven't actually looked into a lot myself, but there is a degree of inaccuracy with double calculations. But I believe this should be the correct answer. So this, after watching the lecture, this really just gives you a chance to flex those muscles of writing your own expressions. A huge part of learning Java is actually just writing the code and spending time at the keyboard writing the code. The concepts are pretty, will sometimes come to you pretty easily, depending on who you are. But a lot of times, just putting those concepts into action is the big hurdle. So here we already knew, order of operations. We just learned how to express it in Java. But the big piece, I think, is just getting practice and actually sitting down, taking your notebook, solving an equation to get for a different variable, and converting that into your own program. So I hope you found this helpful. Let me know. Ping me on email if you have any questions, or on Piazza. Ask your peers. GAs on Piazza. We're all here for you. And hopefully I'll see you sometime in office hours. I'll catch you all later.